Eberhard Wolff has 20 plus years of experience as an architect and consultant, and often on the intersection of business and technology. He's a fellow at INOQ company in Germany, and as a speaker, he talks at international conferences, and as an author, he has written more than 100 articles and books about microservices and continuous delivery. And his technical focus is on modern architecture, often involving cloud, continuous delivery, DevOps, or microservices. And fun fact, even though Eberhard is German, he doesn't drink beer, he doesn't own a car, and he's not into soccer. Eberhard, welcome to Architect of Fwdays.
Yeah, thanks a lot. I'm really happy to be here, and I was really looking forward to the conference, and thanks for the invitation. So I am going to talk about microservices, monolith, and modules. I'm missing the slides. There you go. Excellent. So I was introduced as someone from Germany, so I have news for you, because INOQ is actually also doing hiring internationally now, and there is no need to move to Germany and no need to learn German even, so you can work remotely. There is a website, if you want to look it up, it talks a little bit about our culture. It doesn't really talk about our remote capabilities right now, but that will be there, I guess, in a few days or so. As I was introduced, so I'm an author. I've written a few books about microservices, continuous delivery, also in English. And the reason why I'm giving this talk is because microservices are considered to be a mess oftentimes. So obviously I wrote a book about microservices, and back when I did that, that was actually a hype and people were really interested in microservices and it was all really great. And nowadays they are more like, oh, well, this doesn't really work and it's too messy and there are just too many of those microservices and they are much too small and it's all too complicated. And while I do see how there is a point about that, I have to admit that the alternative would be, well, a monolith. And they seem to think that monoliths are, well, easy to handle. They are somehow simpler and they also look magnificent. So they really do look great. And here is a picture of a monolith. It's at the National Mall in the United States, in Washington. Someone pointed out that this is actually not a monolith. So it's not just one stone, but it's really quite a few stones. But this is probably what people think monoliths look like. Well, let me tell you about one of my, well, it was actually my first large project that I did. And we built a deployment monolith there. And we are talking about like 20 years ago or so. And back then, the compilation time of that monolith was like hours. I checked with my colleagues and actually people remembered that there were systems that took hours to compile. And if I recall correctly, even just starting the system took like 50 minutes. So we would use an application server and it would really take quite a while until the application is up. And there was a very complex integration with a lot of other systems. Actually, our goal was to migrate away from a mainframe monolith. And it was sort of at the center of the business of that company. So it had to integrate with pretty much everything. So therefore, testing was very hard. If you have an application that takes 50 minutes to start, and if you have a lot of systems that you need to integrate with, it's very complicated to test that. And we deployed that stuff over a weekend, over 2 days. And I'm actually not sure about the commercial impact because what we built was a system that was just replacing the monolith. So we didn't really change anything concerning the business logic. Now you could say, well, 20 years ago, but let me tell you about something else that happened not too long ago. And it's actually sort of a typical example of consulting engagements that I have these days. So in that regard, we have a system that is released quarterly, so every 3 months. It would take 10 weeks of testing to test it. Then it would be deployed on 2 days over the weekend. So that means that you have quite a while to develop. Then you have, well, quite a while to really to test. And then you have like these 2 days of releases. So it's to scale. So these are 2 days, these are the 10 weeks, and this is the development that you still have. So they would develop something in one quarter and then release it in the next quarter. And their goal was to do multiple deployments per day, which is actually a great idea, because if you do multiple deployments per day, you get a lot of benefits. For example, you know what works, what doesn't really work, and you get constant feedback from production. So that has lots of benefits. So it is a sensible goal. You can actually show that deploying multiple times per day impacts the productivity positively. So when I came there and I was asked to consult them, I thought that made a lot of sense. But the problem is, how do you even do that, right? So we would need to squeeze the work of 10 days, of 10 weeks in a period of time that is like hours, because you want to do it multiple times per day. And I have to admit that I don't see how you can do that if you are not doing microservices, because then you have parts of the system that can be individually deployed, and then the problem becomes much smaller because you just have to deploy one microservice, not the whole system. So you're not looking at testing the whole system, you're just testing and looking at one microservice. So it's much easier to do that. And then you can achieve this small period of time down here where you would do testing, releases, and development. And this is actually how development should work these days, right? So we should be able to deploy multiple times per day in production. That is the goal. And not just because we want to fix security bugs quickly, but also because it impacts productivity. So I would argue, if people say that monoliths are easy to handle, they are much simpler, they are and they look magnificent, I'm not sure whether we are talking about the same monoliths. So that is sort of my problem. So it seems that those people are saying, well, microservice didn't work, so we are going back to monoliths. And I've been there, and let me tell you, it wasn't really enjoyable. One of the architectures that people claim are actually problematic is the Netflix architecture. So here is a screenshot from a video on YouTube, and it shows the Netflix architecture. And what you see here is lots of systems here, and then you see the dependencies between them. And as you can see, you can't even tell those individual dependencies from one another. So down here, it's still possible to do that, but up there, it's impossible to see what is going on there. And what the people claim them is that, well, nobody can possibly understand this. Nobody can run this. And if you look at this graph, I would argue that they do have a point, right? And I would certainly not recommend this kind of architecture to anyone. But, you know, I checked and Netflix still works. So I have Netflix on my TV, it still works. And they also still launch new features. So somehow this architecture seems to work for them. And in my consulting career, at one point, I realized that we should not ask how to build an architecture. We should try to understand why the architecture that anyone is using works for them. Because if we don't understand how it works for them, we can't possibly improve. So I don't think that a statement that says, okay, this architecture can't possibly work, so it has to be a wrong architecture, is a good statement if you have a company like Netflix that does work and is successful. So we should rather ask ourselves, why is this even working? And I would argue, if you are a developer at Netflix, so here is a person who is developing software at Netflix, obviously they can't understand all of this. So how can they even develop any code? And I guess the answer to that is that this is a small part that they would understand. And this is a fundamental concept that we have in software development. It's called information hiding. The key problem that we have in software development is that we are building software that no individual person can possibly understand. It's the most common problem that we have. And therefore, we need to limit the information that a person needs to do anything sensible with the system, because otherwise they will be overwhelmed and there is no way that they can develop the system and participate in the development. So this is the only way how humans can build such complex systems. And therefore, the question is whether successful modularization is the explanation for Netflix being able to develop this system. Let me tell you that this is just a hypothesis, right? So I didn't work at Netflix. I haven't really looked at their code. It's just a hypothesis. I think it's a likely hypothesis because I don't see how it could work otherwise, but it's just, well, a hypothesis. And again, concerning the architecture, well, Netflix is hugely successful. Netflix depends heavily on software. There is no other asset that they really have. I mean, obviously, they do have movies and TV series, but apart from that, they have the software. So somehow that architecture that people seem to criticize has actually reached the ultimate goal. And the ultimate goal is business success. So it makes Netflix a lot of money. And probably that is because whatever they did was a good fit for the business. Okay, so as I said before, nobody can possibly understand and run this. And now people might say, okay, well, a monolith will be the way out. And I spent some years actually looking at monoliths. And here is a dependency graph that I sort of generated from a monolith. And I still remember one project where 90% of everything of the packages in Java, so packages in Java are a collection of classes, 90% of that were in a dependency cycle. So everything depended on everything. And the problem is, if you have that, then if you change something, you will need to change the next part, and the next part, because everything depends on everything. And therefore, you can't really change any part individually. You rather, everything will be changed at once. So there is no, a change won't be contained in one local part of the system. It will be all over the place. And that is a bad thing because originally you somehow decided that you should separate your system into individual modules, but now you end up in a situation where everything depends on everything. So your split doesn't really work. And in this specific case, there were meetings where the teams would be asked to figure out whether something that needs to be changed in the system would influence them. And every time there was a change planned, every team would be influenced. So it's just a huge mess, right? So everything needs to be done by everyone. And that system costed several million euros and was nowhere close to a first release when I actually came there. However, if you look at microservices again, so here is another discussion that I had with the customer. So we have 1,000 microservices and we lost control, and therefore microservices are bad. Well, if you had a class with 1,000 methods, would you blame that on OOP, on object-oriented programming? Would you say that object-oriented programming is flawed? Well, actually, the problem that we are talking about here, if we have 1,000 microservices, is that we have too many modules on one individual level. So the way to fix 1,000 methods in a class is to build another class and another class and another class until the size of the classes become manageable. The way to fix 1,000 microservices is to come up with more coarse-grained modules that allow you to structure the system. And I would argue that our systems are structured hierarchically. So there is an organization. For example, there is InnoQ, and we have an ERP that tells people what they should do and is also for writing invoices. We have another system, a CRM, that is for the sales process and so on. So in our organization, we have multiple systems. And if this was software that we would develop ourselves, so we are mostly using standard software, then we would have teams that work on those systems, potentially many teams. And then we would have bounded context. This is a coarse-grained module that somehow has one data model. Then we would have microservices or other coarse-grained modules like Java jars, for example. Java jars are a collection of code that you can have in Java. Then we would have, for example, Java packages, so a collection of classes. Then we would have classes. Then we would have methods. So if we have a class with 1,000 methods, we just create another class. And if we have 1,000 microservices, we somehow would put them together in a bounded context, or we would have a team that works on them, whatever. And that way, we can hide away the details. So we don't need to care about those 10 microservices or whatever it is that we put together. We don't need to think about those 10 anymore. We think about a more coarse-grained module. So the point that I'm trying to make is that microservices won't fix your modularization. So the problem that we have is not monoliths or microservices. The problem is a fundamental issue in structuring our systems and in modularization. And I would argue that microservices are sort of a high risk, high gain type of modules. So it's like an investment, right? So if you have an investment that has a high gain where you get a lot of money back, it's actually very risky. And maybe you lose all your money, but if you're lucky, then you get a lot of money back. If you want to play it safe, well, you won't get that much money, but also you're not likely to use money. So risk is sort of the other side of an opportunity. And this is what I'm trying to use as a metaphor here. So if we have loosely coupled modules, generally speaking, we only need to understand one module to do a change. And if we have badly designed modules, well, we have to understand multiple modules and change multiple modules to do anything sensible. And then we have a problem. And this is the case no matter what kind of modules we use. However, if we use microservices, then we need to do more than just change and understand lots of modules. We also need to deploy them together. So we would need to deploy those 3 microservices together that we saw in the last slide. And if we have a crash, if one microservice crashes, it's quite likely that it will influence the other microservices because they talk a lot to one another. So if one of them fails, it will probably also influence the other ones that can't talk to that anymore. And probably also the performance is bad because they talk so much to one another, and that communication goes over the network, and communication over the network is slow. A method call is basically for free. It's very fast. But if you have communication with the network, it's actually slow. So what I'm trying to say is, if we have badly designed modules and we use microservices to implement those modules, not Java jars as I've shown in the last slide, it actually becomes a lot worse what we have to do. While if we have well-designed modules, well, if we have not microservices, but another type of modules, we just need to understand one of them and it won't influence the other ones. But if we have well-designed microservices, we have more benefits. We can also deploy them individually. So it's not just that we can contain the change in one module, we can also deploy that module individually. And if something crashes, it's going to be limited to one microservice. So if we have a memory leak, just one microservice will crash, and probably the performance is also fine. So what I'm saying here is the key to do anything sensible in software development is to fix your modularization. Now, the question obviously is, how do you do that? And I've already said that one of the fundamental ideas is information hiding. And I notice how I'm nowadays actually talking about pretty old stuff, to be honest. So this is a paper by Parnas. Parnas is one of the original pioneers in software engineering. I think the paper is from the beginning of the 70s, so you can look it up here. And my former colleague, Adrian Collier, also did a blog post about this paper, where he talked about it in more detail, and actually Parnas himself commented on his blog post, which I think is great. So let's talk about that paper and what it actually says. So it talks about information distribution aspects of modularization. And it basically says, well, modules can be changed freely if they still meet the expectations from other modules. So if I use a module and I have certain expectations, for example, I would use the interface, right? So I have the expectation that I can do a call to some methods inside there and then get some result. If that is still the case, then the implementation can be changed, right? If I keep the interface, the implementation can be changed. And what Partners also says is that other modules will use all the information about a module. So it's not just the interface that we actually depend on. We might also depend on runtime behavior. So if I have to meet a certain performance characteristic, and if I call that other module, and that module is slower for some reason because they changed the implementation, then I do have a problem, and I'm actually relying on the performance behavior of that module. So that information is also information that I'm using. And the hypothesis that Partners has is that we would eventually use all the information that we can get from a module. So we would use performance characteristics and so on and so on. And what he says is that we should do information hiding. We should hide as much information about a module as possible, because then less information leaks to other modules. And therefore, it's easier to change modules because we can just change the stuff as long as the information about that doesn't leak out. And that's still a valid and fundamental concept. And the way that I think about it is that we have a module and we have some boundaries here. And there are the changeable internals, and then we have public information, right? And the public information is, for example, the interface, and then we have an implementation here, and we can change the implementation as long as the interface stays stable. That's basically the idea. So what are great modules? If we look at a class, in a class, we would have instance variables internally in the class, and then we would have public methods. I think everyone agrees that we shouldn't use instance variables from the outside, so that is internal stuff. And then we have the public methods to actually do anything sensible. And back in the 90s, one way to design classes was to use CRC cards. So CRC is an acronym, and the first C is for class. Second, the R is for responsibility, and the third one is about collaboration. So we would say, well, here's an order service. What's the responsibility? Well, accepting orders, and it collaborates with the order repository that will store orders and several other stuff. Invoice service, for example, to issue invoices. And we could now sort of simulate the system by taking those cards and going through an example, right? So I order this stuff. Okay, yeah. I'm going to accept that order, and I'm going to talk to the invoice service to make sure that an invoice is generated. And then the next person who's responsible for the invoice service would say, okay, I'm going to generate the invoice, and I'm going to do this and that and talk to these other people or other classes. And in domain-driven design nowadays, there is a concept called the bounded context, and it's also, I think, similar. So there is code internally in implementation, and there is an interface, and we would design such bounded context by using a bounded context canvas. And in the bounded context canvas, we would give it a name. So in my case, it's payment. It's a coarse-grained part of the system that is responsible for payment, as it says here. It's processing the payments. It has inbound communication from order processing. It has a ubiquitous language, so these are the terms we would use. A receipt, where it says this is what we got, a payment that says how much was paid, and outbound communication to some payment provider, to bookkeeping, and to, well, order processing again, to tell the order processing that the order was actually paid for. And I would argue that this is very similar to CRC classes. We are talking about collaboration here. So this is inbound and outbound communication, the other stuff that we communicate with. We have the responsibility. So the processing payment is sort of the responsibility. And here it says what some unique terms are that we are using here. So in a way, it's very similar to what we've discussed in the classes and the CRC cards. And I would also argue that the team is very comparable. So a team would take care of, well, code, and it has an interface. And so that's what the team provides for other teams to call and to use. So that is why I think a team is also sort of a module, right? So you would talk to other people and you would negotiate the interfaces, do these kinds of things. And therefore, it's sort of a module that we are talking about. Now, you might wonder whether there is something missing. I'm not sure whether you paid attention, but in the last few slides, I didn't really talk about data, right? I just talked about functionality. And I think this is pretty important. And I think it's forgotten about, sort of. You should build modules by functionality, not by data. And I'm actually serious about this. And it's something that I sort of sneaked in the last few slides, right? The CRC card doesn't really say anything about data, right? We're talking about an order service here. It doesn't talk about the order and what data it would contain. And the bounded context doesn't do that either. So it doesn't talk about the data that we need to do the payment. Because what we are really interested in is the functionality. Obviously, you need to decide how you are going to implement that functionality. So you need to take care of data. But what I often see are architectures like these, where you say, okay, here's the database, and we're going to build a data model in here. And then we have lots of modules that somehow use that data in the database. And this is actually violating information hiding, because we are exposing the data for everyone to use, which we really should hide, right? That's the idea that we have in information hiding. In a class, there are instance variables, and you're free to change the instance variables and the way that you model the system with, as long as you don't impact other modules. And you're giving that away if you expose your data. So an example would be a bank account. So a bank account has a balance. And I could model that as a balance. So I would just store the balance. What I could also do is I could calculate the balance on the fly based on the transactions. If I don't expose my instance variable, so if I don't expose the balance as an instance variable, I can change that. I can change from one implementation to another without anyone noticing. I give that up if I expose the data, and that is also true if I expose the data in the database. So if I have a database table here that gives the balance of each account, then I can't change the model anymore. And that's a problem. And I often see that also with events. So where we have events with lots of data and everyone would use them. And again, that's sort of violating information hiding. I did a video about that. It's, I think, 4 minutes long or so, where I argue that Kafka leads the way to something like a data mesh monolith. So if you're interested, take a look at it and yeah, let me know what you think about it. But let's go back to this bounded context. So bounded context, I think, is very important because it tells us how to build great modules and therefore great microservices. And the fundamental concept is that we have a model inside the bounded context. Sounds fancy, but really it's just code. So some code that somehow models the reality. And a ubiquitous language. Those are the terms that I already spoke about, right? So receipt or payment, those are terms that you would have in a payment bounded context. And let me give you an example how you would build such bounded context. So we would go by functionality, right? So we would have some functionality to write an invoice. And if you write an invoice, well, maybe the VAT, the value added tax, that's a tax that is added on top of whatever you're doing the invoice for, that is probably something that you would do in the same bounded context, because it talks about this sort of the same things. And if you have an invoice, probably you also want to talk about the VAT there. So that might be one bounded context. And again, as I said, we are doing it by functionality. Tracking a delivery, so where is my package? That's a completely different thing. And it talks about different things, right? It talks about a delivery. We don't talk about deliveries in invoicing, so it's a different ubiquitous language. We will put it somewhere else. And the algorithm that tells us how to deliver stuff to the customer is something that is close to tracking. So maybe that's another bounded context, the bounded context for shipping. And then we have something like a shopping cart and accept order. Again, that's not really related to the other things. So maybe that's a third bounded context called order processing. The point here is that we do it by functionality. And now, of course, we somehow have to implement that. And if I have to write an invoice, I would write that invoice to a customer. And I would need to have the billing address. And I write an invoice because products were ordered. So I need to have some information about the product, such as the price. For shipping, I need the shipping address and for the customer, and for the product, I need the size, not the price. So this stuff, this clicker here, it's going to be shipped differently from the washing machine next door, right? That's going to be quite different. And then in order processing, we have product preferences that I might have, or marketing information, these kinds of things. And this is actually very, very different. So at InnoQ, we have an Amazon account and I can just order stuff there. So the billing address would be InnoQ in Monheim, small village at Rhine River. But the shipping address would be my home here in Kaiserslautern, which is several hundred kilometers away. So it's two very different things. The customer is InnoQ GmbH, the business entity for invoicing, but for shipping, it's me, because I want to get that stuff that I ordered because I need it for work. And that is the reason why this is, well, those are two very different things, as I said. So basically the point is that the data model is, well, internal. So it hides most of the design decision, how data is stored and these kinds of things. And therefore, if you start doing stuff by functionality, like bounded context do basically say, then you have sort of natural grade modules. And this is why domain-driven design and bounded context is so very important, because I think that they sort of give us the key to build great modules, and then we get all the benefits from microservices. But does that even matter? So here is a book that I think is worth reading. And it's a book that argues that you should, well, deploy multiple times per day. And this book basically says what is important is enabling team to make changes to their products or services without depending on other teams or systems. That's the key, they say, to become more productive. And they actually did scientific research on that. So I actually believe this is a statement that is very likely true. And they claim that, well, discussion often focuses on tools and technologies. So should we do microservices, serverless, Kubernetes, Mesos? And they say that those are the wrong questions to focus on. Tools are irrelevant if people hate them or they don't achieve the outcome and don't enable the behaviors we care about. And when I read that the first time, I was like, that's weird, right? Because I would argue that microservices help us to have independent teams. But then I remembered a discussion that I had where I basically said that, right? Microservices enable independent deployment and independent technology decisions. So a team can just decide to build that microservice with Java or with a different programming language, and they can deploy it on whenever they like. And that client that I was consulting then said, well, we are doing microservices, but we deploy them all at once. And some architect makes all the technology decisions. And that's actually what I believe the book is talking about, right? It's not about the technology, it's about the culture, and it's about whether we enable teams to make these independent decisions. That's the point. And microservices might support that, but it's wrong to focus on microservices. And a question that you could ask here is, why are you doing microservices? There might be good reasons. It's not just independent teams. There are other reasons to do microservices, but the benefit of independent teams, they don't get that if they do it this way. So microservices won't fix your organization either, right? So that's the other point. So in conclusion, monoliths might not be as simple as you think. Let me tell you about that. That's truly a lesson that I learned. Microservices might not be as bad as you think, and we should go back to the basics. So as I said, I'm back to talking about, well, just like today, right? I'm talking about papers from the 70s because those are the fundamentals to do proper software engineering. And it's therefore about modules, and it's about organization and these kinds of things. If you enjoyed the talk, send an email to Fwdays 2022, and you will get a link to a Dropbox that includes the slides. I've written a few books, so some of them are free. So the book about service meshes, and also there is a booklet about microservices, actually 2 of them. You get them for free, and then there are sample chapters from the other books. That's an Amazon Lambda script and a small microservice, so your email address will be locked for 14 days. That's the minimum that I could set up there. And if you did anything wrong with the address, I will handle it manually. And as I said, we are hiring. We are looking for people to work with us. No need to learn English. No need to relocate to any other location. So I would be happy to hear from you. And now we have some time for questions, right?
Yeah, exactly. Thank you for a great talk, Eberhard. We have a lot of questions. I think we can ask a few of them here and then move to Discord chat. So the first one would be, does it make sense to have independent databases for each model or group of models, or is it better to have a single database shared across all the models?
First, it depends on what you actually mean if you say database. So if we're talking about a database server, then I don't really I would say it's not a fundamental problem to share one database server. Obviously, if that server fails, then all of your microservices will have a standstill. And also, if that database server doesn't scale, then you do have a problem. But that's just a technical constraint, and you're probably very well of that. Things are different concerning database schemas, and that's what I was trying to say in the talk. If you share a database schema, it means that you are reusing the way that you model the data, and that is something that should be hidden internally in modules. And as I said, if I talk to developers, then usually they say, well, instance variables should be hidden. You shouldn't share instance variables. For some reason, that is not so clear if we talk about databases, while really it's basically the same thing, right? We are talking about data structures and shared data structures across modules. It's just that classes are more fine-grained modules compared to microservices, and therefore I'm not sure why why we have that discussion. But it is a common one, so therefore the question was really a great one, and it's one of those fundamental problems. I mean, that's why I put it in the presentation. It's one of those fundamental problems that I see in a lot of clients. You go there and you notice that they have these large database schemas that are shared, and they can't really deal with that. So thanks a lot for that question.
Thank you for the answer. And the next question would be, what is your preferred technique to define domain model and bounded context?
So one obvious answer is to use event storming. Event storming is a technique where you would use Post-it or stickies and stick them to a wall, and then you would write down the events, and then you would bring them in an order, and you can with some tricks you can identify bounding context that way. And the reason why this is quite a good way of doing it is because you can do it with domain experts. Because so to ask domain experts to write, a sticky that says invoice has been delivered or whatever, that is something that they are able to do. So you will be very close to the business, and I think that's core of domain-driven design, right? It's called domain-driven design for a reason. It's called domain-driven design because the domain drives the design. So domain experts that actually talk to you and care about the design, that's a good thing. The other thing is something that I try to show. So I'm sitting in some conference room and some architecture is presented to me. I can't do an event storming. So how do I figure out whether that's a good bounded context or not? The question is this oriented by functionalities? That's the other thing that I was trying to say. So invoicing and the calculation of the VAT, the value added tax that goes on top of the amount of the invoice, is that something that belongs together in one module? I would argue yes, but you could have a discussion about that. And that's basically about, to me, this is about fundamentally how we build modules. Let's stick stuff together, functionalities together that belong together, and that's the other way to reason about bounding context and modules in general. So that's the other technique that I'm using.
Thank you very much. Yeah, the event storming works pretty well from my experience. And we have another one question that is not so technique, but the career one. Any advice how to become a software architect and consultant? Because the person is asking, he's working as a developer for 8+ years and wants to understand at least vectors to look forward to obtain a position of architect and consultant. What was your way, or what do you recommend?
Yeah, actually, that is a question that is very dear to my heart and very important to me. If you, I talked about software-architektur.tv. So there is a link to the shorts somewhere in the slides. And if you look at that website, there is also, I'm afraid it's a German, it's only in German, so sorry about that. I should do something in English too at one point. So I did interviews with several of my colleagues and also with several other people about their way to become whatever they are doing right now. And what I found very interesting is that those ways are very different. So there are persons like me. I basically, I studied computer science and it was a very straightforward thing. And then there are other people who, did this and that, and then they ended up in IT at one point. So I think there are quite a lot of different ways to go there. If you are a developer with this kind of experience, I would argue that in a way you're probably already an architect because you probably make decisions that you would consider software architecture. So then it's about the title, right? So the question is, how do you make sure that it says software architect on your business card? And this is something that is very, I think, related to how the companies work. I would definitely try to think more about architecture, influence that more, because as a developer, you should be able to do that if in any project. And then it's also about skills. So I'm a member of the ISAQB, International Software Architecture Qualification Board, and you can get certified there. And we have trainings, but you can also take the certification without any training beforehand. And if you're looking at the skills that you have to build architecture, I believe that we have a very good curriculum to talk about that. So that is something that I would definitely recommend. And I'm a member of that organization. It's a non-for-profit organization because I actually believe that we are doing a pretty good job at providing that fundamental things that you need to understand to become a software architect? So again, a very good question.
May I ask you to post the link to the websites you were mentioning? We can do it in Discord channel.
In the September 24 conference thingy?
Or in the track A. I'm asking questions that are
track A.
posted.
I'll definitely do so, and I'll post the link in a few minutes.
Thank you. And the last question that will be in a stream would be, can we make a layer between database and the rest of the system? But will it make the system depend on this layer? How to break such dependencies on data layer dependency? I've read it as it's stated, but
yeah. So in layering, usually the problem is that the layers on top, like logic, would depend on the layers at the bottom, right? So persistence. So logic would use persistence, and you could argue that's not a very good thing, because then well, you're basically depending on technical details, even probably. And the way that you can solve that is using hexagonal architecture. So in hexagonal architecture, at the core there's the logic, and then on the outside there are ports and adapters. So you would have one port that talks to the database, for example. And from a technical perspective, how you do that is by defining the interface that the core expects in the core. So there would be an interface that says, I expect there to be a repository, and the repository should give me access to customers, for example. And then the port to the database would implement that. So the port to the database would depend on the core, but not the other way around, because the interface is defined in the core. Let me add that, how shall I put it? Obviously, it is nicer to do it that way, right? But I don't think that this is how you are successful in a project. It's much more important to figure out what the customer wants and how the business logic should be structured. So if you show me an architecture and you say we are using an hexagonal architecture, I would rather prefer if you show me an architecture and you tell me, okay, these are the parts. And we have one part that talks about invoicing. We have another part that talks about order, and we have a third part that talks about delivery. This is what I'm interested in, because we need to support the business. And I'm not really that interested, to be perfectly honest, whether using hexagonal architecture or layered architecture, because there is a technical benefit, but it's a slight benefit. If you get the architecture wrong concerning the business logic, that is something that really hurts the project. While the other thing, well, okay, if you need to change the whole persistence layer, then there might be a problem. But that's not something that you do every day. What you do every day is you implement some kind of business logic. So you should focus on that.
Thank you very much for a great talk and for the empowering Q&A session. I think there are more questions to answer on. I'm inviting all who wants to continue discussion in the Discord voice channel Eberhard Wolff.